Next theorem is interior extreme theorem. So question is state and prove interior extreme theorem. Statement of this theorem. Let's see the interior point of interval I, at which the function f from I to R, that is real world function, has a relative extreme. Then if the function f is differentiable at point C, means f dash C exists. Another format of the statement is what? If the statement f is differentiable at x is equal to C, means what? F dash C exists. Then prove that f dash C is equal to 0. So this, up to this, then all the things are given. That is, we are given that C is the interior point of the interval I, and this function f from I to R has a relative extreme, and the function f is differentiable at a point C, that is f dash C exists. So all these things are given, and we have to show f dash C is equal to 0. So let's see this be the interior point of the interval I, at which the function f has a relative maximum. Relative maximum means what? The image at point C is large than all the images under the function f. That is, f of C is greater than or equal to 0, is greater than or equal to fx for all x belongs to I. This point, at the point C, the function is relative extreme. Means what? Either maximum or minimum. Either maximum or minimum at the point C. We assume that the function f is maximum at the point C. And so f of C is greater than or equal to f of x for all x belongs to I. That is, the image of the point C is larger than the image of all the remaining elements. So the function has a maximum at the point C. The function is maximum at the point C, means uh, the image of C under f is larger than the images of all the remaining elements. That is, f of C is greater than or equal to f of x for all x belongs to I. So this is the given in the theorem that C is the interior point and the function f is what? A relative extreme at the point C. So we assume that the relative extreme means what? Either maximum or minimum. We assume that f has a relative maximum at the point C. So we have this, that f of C is greater than or equal to f of x for all x belongs to I. So the maximum or minimum of the function f means the maximum or minimum of the set of images under that function. Okay. So this is the concept of maximum of the function or minimum of the function. So we have f of C is greater than or equal to f of x for all x belongs to I. And therefore f of x minus f of C divided by x minus C is greater than or equal to 0 if x is less than C. That is, if x is less than C means x minus C is negative. And here fx is less than fc. Therefore fx minus f of C is what? Is less than 0. So less than 0 quantity and less than 0 quantity, negative by negative get positive. And if f of C and f of x both are same, then we have their difference is 0. So the sign is what? Greater than or equal to 0 if f of x, if x is less than C, that is x minus C is negative. And if x is greater than C, that is x minus C is positive, then negative by positive is less than 0, negative quantity is less than 0. And if f of x and f of C both are same, they do have equal to 0. So f of x minus f of C divided by x minus C is less than or equal to 0 if x is greater than C. So assume that f is differentiable at x is equal to C. So this is the statement. Also we are given that the function f is differentiable at x is equal to C. So assume that f is differentiable at x is equal to C. Therefore f dash C exists. And as f dash C exists, f dash C is equal to f dash C plus is equal to f dash C minus. That is the right hand derivative, left hand derivative, and the derivative, all these three are same because the function is differentiable at x is equal to C. And what is f dash C? Now therefore f dash C is equal to f dash C plus, take f dash C as f dash C plus, and f dash C plus is what? Limit extends to C plus f of x minus f of C divided by x minus C. This is the right hand derivative. And this extends to C plus means x is greater than C. And if x is greater than C, then f of x minus f of C divided by x minus C is negative. And therefore its limit f of x minus f of C divided by x minus C, its limit is less than or equal to 0 because extends to C plus Means x is greater than 0, and so this quantity is less than 0, negative, less than or equal to 0, and therefore its limit is also less than or equal to 0. Then take f dash c as a f dash c minus, and then is equal to f dash c minus definition is what? Limit x tends to c minus f of x minus f of c divided by x minus. And again, x tends to c minus means x is less than c, and if x is less than c, then f of x minus f of c divided by x minus c is greater than or equal to 0, and therefore its limit is greater than or equal to 0. And so from 1 and 2, what we have? From these two, we have f dash c is less than or equal to 0, and from this we have f dash c is greater than or equal to 0, and this implies f dash c is equal to 0. Because f dash c is less than 0 and greater than 0, it is not possible. F dash c is less than 0 as well as greater than 0, it is not possible. So f dash c is equal to 0, and hence theorem. That is where to show f dash c is equal to 0. So this is the interior extreme theorem. So these four theorems, that is Rolle's theorem, Lagrange's mean value theorem, Cauchy's mean value theorem, and interior extreme theorem. These four theorems are important as far as the exam concerned. Then problems on these four theorems. So problem on the first three theorem, that is Rolle's theorem, Lagrange's mean value theorem, and Cauchy's mean value theorem. These problems are also important as far the exam concerned. So verify, questions are, examples are of this type. Verify Rolle's theorem for the function fx is equal to gx cube minus 4x on the interval minus 2 by 3, 2 by 3. So we check that this function fx satisfies all the condition of Rolle's theorem. First we check the three conditions of Rolle's theorem. What are the three conditions? That the first condition is the function is differentiable on the closed function is continuous on the closed interval. This function is continuous on the closed interval. Then function fx is differentiable on open interval. And the third condition is the value at the first point is equal to value at the second point for the function. So we will check the third condition first, that we find f of minus 2 by 3 and f of 2 by 3. So what is f of minus 2 by 3? Just substitute x as minus 2 by 3. So minus 2 by 3 cube minus 4 minus 2 by 3. So minus 2 by 3 cube. So minus 2 cube is minus 8 because it is third power. 3 cube is 27 minus 2 by 3, and the calculation is what? Calculation is minus 8 by 3 plus 8 by 3, that is 0. We have the answer at minus 2 by 3 0. Then f of 2 by 3 at 2 by 3, the value of the function. So we have 9 2 by 3 cube minus 4 2 by 3, again 8 by 3 minus 8 by 3. So answer is 0. And so what is your observation? F of minus 2 by 3 is equal to f of 2 by 3. That is f of a is equal to f of b. And the first two conditions, clearly this function fx is what? Continuous on closed interval, right? Both sides closed. Minus 2 by 3, 2 by 3, right? Closed bracket. Here also closed bracket. And derivable or differentiable on open interval, minus 2 by 3, 2 by 3. Because this fx is a polynomial function, this fx is a polynomial function, 9x cube minus 4x is a polynomial function, and polynomial function is continuous and differentiable everywhere. That's why the function fx is what? Clearly or right, clearly or obviously, the function fx is continuous on closed interval minus 2 by 3 plus 2 by 3 and derivable or differentiable on minus 2 by 3 open interval minus 2 by 3, 2 by 3. And hence fx satisfies all the conditions of Rolle's theorem, right? Here R capital. So fx satisfies all the condition of Rolle's theorem. That is the function is continuous on closed interval, function is derivable on open interval every on the interval, and the value at first point and value at the last point, that is f of a and f of b, both are same. And hence fx satisfies all the condition of Rolle's theorem, and therefore by Rolle's theorem there exists at least one point c belongs to open interval minus 2 by 3 plus 2 by 3 such that f dash c is equal to 0. Now we have to find the value of c. So what is f dash c? So first find f dash x. What is f dash x? Is 27x square minus 4. And so what is f dash c? 27c square, right? 27c square. 27c square minus 4 is equal to 0, or take 27x square minus 4 is equal to 0. And then find the value of x. Right here, either c. F dash c is equal to 0 means 27c square is equal to 0, right? C, notation c. Then 27c square is 4. C square is 4 by 27, and therefore c is what? Plus minus 2 by 3 root 3. Take the root of both sides. 27, root of 27 is 3 root 3. And hence, these values of, out of these two values of c, both the values plus 2 by 3 root 3 and minus 2 by 3 root 3 both belongs to this. If we check by using calculator, then 2 by 3 root 3 lies in this. So note that the sentence is what? Note that plus minus 3 root 3 belongs to open interval minus 2 by 3, 2 by 3. And hence Rolle's theorem is verified. That is, there exists at least one point. What are that? We have 2 points, such that the value, the derivative at that point are 0. F dash c at these 2 points are 0. So Rolle's theorem is verified. So next, verify the Rolle's theorem for the function. Again, the same function, polynomial function. First find the value at the first point and last point. So these are the problems for homework. So the answer of the third number problem, fx is equal to e raised to x sin x minus cos x on this pi by 4, 5 pi by 4. So the first value at 5 pi by is pi, at pi by 4 is 0. Then value at 3 pi by 4, 3 pi by 4. It is 5 pi by 4. The value at 5 pi by 4. This interval is what? Pi by 4, 5 pi by 4. Then value at pi by 4 is e raised to, right, pi by 4 here. E raised to pi by 4. Here write pi by 4. Sin pi by 4 minus cos pi by 4. And sin pi by 4 and cos pi by 4 both are same. Therefore, their subtraction is 0. And therefore, we have answer 0, right? Sin pi by 4, value of sin pi by 4 and cos pi by 4. Again, the value at 5 pi by 4, sin 5 pi by 4, e raised to, right here, e raised to 5 pi by 4, in bracket sin 5 pi by 4 minus cos 5 pi by 4. And the value of, right here, e raised to 5 pi by 4, and the value of sin 5 pi by 4 is minus 1 by root 2. And the value of cos 5 pi by 4 is again minus 1 by root 2, so minus minus become plus 1 by root 2, and therefore we have answer 0. Answer 0. Cos 5 pi by 4 is minus 1 by root 2. And therefore the value at the first point and value at the last point are same. So right, f of pi by 4 and f of 5 pi by 4 both are same. And clearly this function fx is continuous on closed interval, right here, closed interval pi by 4, comma 5 pi by 4, and differentiable on open interval pi by 4, right, first pi by 4, comma 5 pi by 4. Because this function is what? Is a trigonometric function, exponential function, and trigonometric function. And trigonometric function is continuous and differentiable everywhere. Therefore, this function is continuous on closed interval, differentiable on open interval, and the third condition is already satisfied by this function, that is f of a is equal to f of b, and therefore all the conditions of Rolle's theorem are satisfied, and therefore by Rolle's theorem there exists at least one point, c belongs to open interval pi by 4, comma 5 pi by 4, such that f dash c is equal to 0. So what is f dash c? First find f dash x by using u into v rule. So f dash x is this, e raised to x, e raised to x, derivative of sin x minus cos x in bracket is sin x, derivative is cos x, and derivative of cos x is minus sin x. So minus minus become plus sin x, plus the second bracket, second quantity, v sin x minus cos x into derivative of e raised to x is e raised to x is equal to 0. Substitute x as c now, or directly solve this. So we have this, after simplifying, this e raised to cos x, e raised to x into cos x, and minus e raised to x cos x 0. E raised to x sin x plus e raised to sin x is 2 times e raised to x sin x. Then shift the 2, we have e raised to x sin x is equal to 0. And therefore sin x is equal to 0 because e raised to x is not equal to 0. We know that a into b is 0 if and only either a is 0 or b is 0. So this e raised to x is not equal to 0 for all values of x. And therefore sin x is 0. and therefore x is what? Sine inverse 0. So what are the values of sine inverse 0? 0, pi, minus pi, 2 pi, minus 2 pi. Because sine 0 is 0, sine pi is 0, sine minus pi is 0, sine 2 pi is 0, sine minus 2 pi is 0. And out of these values of x, the value pi lies between pi by 4 and 5 pi by 4. That is, we have at least one point in this interval, say that the derivative at that point is 0. And therefore, Rolle's theorem is verified. Therefore, Rolle's theorem is verified. Then answer of this first question, fx is equal to, the second, fx is equal to 2x square plus x square minus 4x minus 2 on the interval minus 2 minus root 2 plus root 2. Okay. So find the value at minus root 2 and plus root 2. Both the values are same. Both the values are same. If both the values are not same, then write the function fx does not satisfy all the condition of Rolle's theorem, and therefore Rolle's theorem is not applicable. So if the conditions are not satisfied, so this is the polynomial function, so it is continuous and differentiable. There is no problem about the condition number 1 and 2. But the third condition, that f of minus root 2, value at f of minus root 2 and the value at f of root 2, these two are not same, and therefore Rolle's theorem is not applicable. Then the answer of fourth problem, this fourth problem, the interval is AB, close interval AB, that is find f of A and f of B, and both are same. Denote that both are same. F of A and f of B both are same. Log 1, that is 0, both the values are 0. Clearly the function is differentiable, continuous on closed interval AB, differentiable on open interval AB, because logarithmic function is continuous and differentiable, and fx satisfies all the condition of Rolle's theorem. By Rolle's theorem, there exists at least one point C belongs to open interval AB such that f dash C is equal to 0. So what is the derivative of log x square plus fx is this log x square plus AB plus a plus b x. So simplify this log x square, log a by b rule, log a minus log b, and then derivative of this quantity is what? Log a, log x derivative is 1 by x. So log x square plus ab derivative is 1 by x square plus ab into derivative of x square plus ab is 2x. Similarly, log a plus b x derivative is 1 by a plus b x into a plus b is equal to 0, and therefore we have this quantity 2x divided by x square plus ab. This quantity is 1 by x. Then after simplification we have this. So x is plus minus root ab, plus minus root ab. Okay, and this root ab belongs to open interval ab, and therefore Rolle's theorem is verified. This is the answer of question number, example number 5. The value at 0 and 2 both are same, and therefore by Rolle's theorem and the derivative of x minus 2 e raised to minus x, either use u into v into w rule or u by v rule. By shifting e raised to minus x to denominator, use u by v rule or use u into v into w rule. So we have this answer root 2 x, where the value of c or x is root 2. Rolle's theorem is verified. So verify mean value theorem for the function fx is equal to log x on closed interval 1e. Now there are two conditions in mean value theorem. There are two conditions, that the function is continuous on closed interval ab and differentiable on open interval ab. The third condition is that is the value at the first point and value at the last point. This is not the condition of mean value theorem. So write clearly or obviously the function fx is continuous on closed interval ab, closed interval 1e, and differentiable on open interval 1e, because the logarithmic function is continuous and differentiable everywhere. So in each theorem, in verification of each theorem, that is Rolle's theorem, Lagrange's mean value theorem, Cauchy's mean value theorem, there is no need to prove that the function is continuous and differentiable. Directly write the function is continuous on the closed interval and the function is differentiable on the open interval. No need to prove give the proof of this continuous and differentiability. Okay, don't given the proof of the continuous function, that is how the function is continuous, how the function is differentiable. Directly write the sentence, because we are given the functions like logarithmic function, trigonometric functions, polynomial functions, And these functions are always continuous and always differentiable. Continuous everywhere, continuous, differentiable everywhere. So directly write. So both the conditions are, all the conditions of the mean value theorem are satisfied by the function, and therefore by mean value theorem there exists at least one point C belongs to open interval 1e such that f dash C is equal to f of b minus f of a divided by b minus a. Okay, so solve this equation. So f dash C, so f dash x is 1 by x, and so f dash C is what? 1 by c. What f dash c, f of b is log of b is e, and a is 1. So log f of b means log, log of b means log of e, f of a means log of a, log of a means 1, log of 1, e minus 1. B is e and a is 1. So this interval 1 e, a is 1, b is e, and then 1 by c is equal to log e is 1 minus log 1 is 0 divided by this. So 1 by c is 1 by e minus 1, c is e minus 1, and this e minus 1, c is equal to e minus 1 belongs to this open interval a 1e. Note that c is equal to e minus 1. We have only one value of c, and that belongs to 1e, and therefore Lagrange's mean value theorem is verified. What is the Lagrange's mean value theorem? There exists at least one point c belongs to this interval which satisfies this equation. That point is e minus 1, and therefore Lagrange's mean value theorem is satisfied. So next example is again verify mean value theorem, and we are given fx is equal to and gx is equal to, we are given two functions, and that's we have to verify mean value theorem, and the fx and gx are given means we have to verify the Cauchy's mean value theorem, because in order to verify Cauchy's mean value theorem, in example we are given two functions, and in order to verify mean value theorem only one function is given. So verify mean value theorem, here is only one function is given, so we have to verify Lagrange's mean value theorem, and here we have to verify mean value theorem, but the fx and gx are given means we have to verify the Cauchy's mean value theorem. So we will see this remaining problems in the next lecture.